Hello, Malvan here. And this time, for a long time being, I'm going to talk about Vide. Or more specific, I'm going to talk about Smartlists and what you can do to them. No, not to them, but what you can do with them and how you can use Vide to create them and how you can perhaps tickle some performance out of your own programs while using them. I did this video already 2 times and always there was something wrong. So I don't know if you are really going to see this one here. But I discovered that there's much to talk about. So this will probably not be only one video session, but 2 or 3 or something like that. Anyway, let's start slow and show you what smart lists are good for. They're good for some things and they are bad for others. For now, I'm going to show you what I think they are good for. An example for that, I'm going to do an example from Vectrex. For this, I'm going to load part of the title screen of Vectrex. Title big. You can see this is a Vectrex title. And this title is made of different little pieces of vector lists. These are down here. I call this a scenario. To see the complete title, you can join them, and here you can see a vector blade. I can scroll a little bit. This is a gigantic vector blade title, and this consists of 21 separated paths. Yes, I'm going to display this title using a normal vector list. A normal in the sense of I'm going to do it with a sync list, a scenario list. So all these 21 smaller vector lists are drawn with sync lists. Just to, as an intro to this. It must be runnable. And one thing I'm going to fix here is the scale factor, because this list is so huge, we have to use a tiny little scale factor here and to be comparable later on with smart lists. So let's execute this. Here you can see this is the vector blade title. It's a little bit at the top. I can correct that later. But the important thing now is how fast or how slow this runs. This for now is running in 75,000 cycles. This is, how much hertz is it? I don't know, less than 20, I think. Less than 20 hertz. Your eyes will start to crumble if you look at this on your Vectrex. I'm going to push it a little bit down to be more centered, to be comparable later on. Little thing, this is a scenario. I told you this, and this is the collection of all scenarios. You can, if you build these scenarios correctly, you can switch between these two very easily. I clear this up. Then here it is an empty list, and if you are switched here to scenario and click join, then all these vector lists are joined into one vector list. This is what happened here now. There is, if these are built correctly, all separate closed path, you can also do the reverse. This is the complete vector blade, and here you have a tab scenario, separate paths as scenario entries. This is what you can do here, and these are exactly the same as before, because the scenario was, for my taste, correctly built. So these are two reverse functionalities, join and separate path as scenario. What I'm going to use this for now is to clear the scenario again, select, switch to vector, select all in the vector list, pull it down a little bit, and separate path as scenario. And if we now draw this sync list again, you will see that it moved down, but we have to fix up the scale again here. So if you execute this now, it will look more or less like the, well, not really. I should have moved it a little bit to the left. Yeah, like that, and clear, and do here, and do that, and then this again, and finally at one stage I will be satisfied with the result, perhaps. Okay, this is now our base vector blade, so to say. This will be compared to every other vector blade you will ever see. Anyway, just moving it down reduced the time needed for drawing quite a bit. It's now displaying in 63,000 cycles. Still, it's less than 25 hertz. It still hurts the eyes and looks ugly. So now, Smartlists. I'm going to do exactly the same, just do not press this draw sync this button, but go to this tab over here, Smartlists, build scenarios with Smartlists, preferable runnable so they can run, and just execute them. Stop. I'm going to explain that later, but so now this is exactly the same image as before, but drawn with Smartlists. And as you can see, this is now drawn in 18,000 cycles. It uses less than 1/3, way less than 1/3 the cycles than drawn with DrawSync. This is a huge, a mega huge difference. This does not flicker at all on the Vectrex. It's looks beautiful, and with just exchanging normal vector draw routines with Smartlists will gain you so much speed. You cannot do it in all cases. Let's warn you directly here. But when you can, it's worth it. Smartlists, where do they come from? For me, the official Smartlists started when Christoph Tutz released Vector Patrol, V Patrol. He used Smartlists there. I think Thomas and I also separately used similar kind of drawings before. So perhaps you might argue that it's not really originated alone with Christoph, but for me, we didn't use it to this extent, this clarity, and this following through with the concept. So I would say I got the idea for a Smartlist from Christoph Tutz, and all credits go to him for these. What these Smartlists actually are, just let's look at a smart at the list here. I'll open it in editor. It's a little bit colored there, and you can discern it better. This last thing here is one vector list. This is actually this. Where is it? One moment. I'm going to find this. This is only this small. I think it's part of the E in Vector Blade. This is a last list here, and this is this list over here, or in the where the editor, or over here. What this is, these are the normal coordinates, and these are function calls. You might even think, if you are a programmer, that these lists are sort of object-oriented, because the data itself knows how to be handled by providing the function for it. So this is this line represents one vector, and this vector starts virtually at 0.0, and it moves 23 positions upwards at minus 77 hex positions downwards. So not downwards, left. This is a horizontal position, this is a vertical position. And if you look at the vector blade, each of these lists you can imagine starts at point 0, 0 in the middle of the screen. And what this actually does, it goes a little bit up and it goes far to the left, up to here. And now this thing here is drawn. So these first lines do the actual move from the middle to the start of the vector, to the start of the polygon, so to say. I'm going into that a little bit more later on. And now we have the function start draw. So I don't know which one of these vectors here is the first one by heart, but what it does, it starts the first line drawn from the current position to again -11, so it goes downward, and -47, it goes further to the left. So it's might be this vector over here. And this is a function that is used. It's actually a function. You can go to it. You can see this is a function with which one vector is drawn. I'm going to leave it here for now. I'm going to talk a little bit more in depth about this later on. But for now on, you might have seen, or you probably have not seen it, but I can show you the generation tab for Smartlists has a whole lot of checkboxes, buttons, and things to configure it. When you start up, it has a default setting, and the default setting by now shouldn't be default anymore, but right now it still is. What you see here, this is what I call old smart lists. For Vectorblade, I optimized the smart lists, and this whole tab actually exists only because of Vectorblade, because I needed some programming help, tools, utilities to actually do all the vector lists and to convert them to a usable, good format. So this is all more or less Vectorblade originated. But I implemented a different sort of smart list for Vectorblade, and these can be invoked by pressing Vectorblade smart lists. And actually, what you should use is more or less, I can't think of any reason why you shouldn't. Perhaps there is one, and I will write it down in the comment section or something like that. But right now, I would say always use Vectorblade smart list. You generate them just the same. Just for info, you can now look again at the cycles. This is 18,300 by just switching to Vectorblade smart lists and executing the completely same image, just uses 15,000 cycles. So again, you have optimized your drawings by another 20% or so. It's this is one of the main reasons why you should use Vectorblade smart lists. Possibly it can still be optimized, but the thing is, the smart lists as they are pretty near, I think, to an optimum, pretty near to the extent that sometimes they are too optimal and are not displayed correctly. I cannot guarantee that it is not the case that they will not display correctly. Sometimes you just have to try things out on real Vectrex and look how it looks. And the real Vectrexes are also different. There are cranky ones, there are less cranky ones, there are older ones, there are brighter ones, ones with more drift, with less drift, with drift to the left, to right, to the top, to the bottom, and so on. Possibly before you do a release of your own programming, test it out with as many Vectrex as possible. This does not only apply to the smart list, this actually applies to your complete program. Believe me, if there can go something wrong, there will go something wrong. Anyway, Vectorblade smart lists. These are again a little bit faster, and the structure is slightly different. You can see that if you where okay, the old editor was closed, So this is a new kind of smart list, the vector blade smart list. I think I'm going to generate the other one just to show the difference, and open it also in a tab. So here you can see the different kinds of smart list. At the bottom are the old ones, and at the top are the vector blade smart list. Here you can see this smart list is shorter. It has less entries, but they're more or less the same, more or less, because what you see here is a draw double or a move double. Double, 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 double. This is 8. This means this this move is made 8 times actually. And what this one here does, you see, this is exactly the same move. This is 28 vertically and minus 77 horizontally. And here now is a function called octo. Octo stands for 8. So this is actually the same as 4 times double is 8. So we have a octo function here. This is again a little bit optimized because these are more or less 4 calls to a function. This is just one function call, so there are a few cycles saved, and a few cycles saved here, and a few saved cycles there. Well, this accumulates to, in this case, 3,000 cycles saved. There are more differences, but this is one obvious difference if you compare them together. The other one is, this one has one coordinate, not a coordinate, a parameter more. As you can see, this is just a y coordinate, this is the x coordinate. You also have a y and x coordinate here, but in between there's a 0, 1, a 1 actually. This has to do with internal optimizations. In this list, this is put to register A, this is put to register B, and so these are the coordinates you can think of as you would provide to a move to or something like that, just a coordinate pair. In this case above, this one goes to register B, and this word goes to register X. And what is actually done later on is you put the X register into via register B, and at once, since this is a 60-bit value, you program register port B and port A of the wire with the correct values. It's faster. This list is altogether a little bit more optimized to, well, quench the last drop of speed out of the Vectrex. So this is an overall structure. The function names I use for smart lists are actually generated by Vide. Vide can generate function names for smart lists that are not implemented yet. There are just so many possibilities, and it doesn't make sense to have a library of smart list calls that is way huger than you usually use. There's a default implementation that has, I don't know how many functions, but is about 1.5K long. These are just smart draw functions, 1.5K. These are all present in the template folder of Vide and called Smartlist something. Smartlist for animations, Smartlist for scenarios, Smartlist for just drawing, and so on. You have to look at the template directory. But what can actually happen is that Vide can generate function names that are not available within this template. It does not generate the functions itself, it just loads the template. If this happens, you have to provide the function. This is usually not too complicated because there are already 40, 50, 60 functions, and you just have to look at them and copy and paste and possibly add or remove 1 or 2 lines. Yes, I don't think that this will be much trouble, but it can happen. Yes. Further on, the smart list, how do they work? Smart list or one vector list of smart list is, so to say, stated. There are 2 states. It can be in the state move, and it can be in the state draw. And all Smartlists start in the list in the mode draw move. Oh my God! Start in the mode move. So what this then does is, as said before, it starts from point 0, from the screen center in this case, and moves to this position. And once it wants to draw, it changes the mode, and mode changes are always indicated with a name start at the start of the naming convention, and then either start draw or start move. I don't think we have any start moves here. And then there's a numbering. This goes from single to double to quattro to hex to octo, and this all means single 1, double 2, quattro 4, hex 6, octo 8. This has actually to do with how large a vector you want to draw. Usually when I use Smartlist, I always use a scale of 9. Why that is, I'm going to do that later. But do I go to that later? No, I'm going to turn around and start a new topic and come back later to this one here. I told you this is going to be confusing, but I hope that the whole picture, once this is finished, makes it all clear. The vector blade. This is one of the lists. Where is it? Where can I find it? This is one of the central lists. This is this path, vector path, so to say. And if I look at the list, then you can see that the length of the vectors is within Vide. You can see them here. The longest vector of these is probably this one over here. This has a length of over 1000. 1000 is not 8-bit anymore. It's actually 16-bit. And Vectrex cannot cope with that very well. But you can see it is displayed here, and the export does not really bother about it. I think this one is actually the list 0. It's somewhere in here. Well, doesn't matter now. What the Smartlists do, the same as the draw sync list, otherwise we couldn't have drawn this thing in a sync list, is it looks if a vector is larger than 8-bit, or value that is the border value, the maximum value, then it splits the vectors in 2 halves, or 2 approximal halves, so to say. And this is what happens here. This 1000 coordinate vector is probably, don't know, perhaps divided by 8, perhaps by 10 or something like that. And then this is an old move. This is not vector blade. I'm going to vector blade it again. Then we go to 0. So I think this is really the first list. What this does, I'm going to explain it again, even if I had it did do it before. Starting at 0, it goes up here. This means it goes way positive y and positive x. This is this positive y, positive x, and it does so for 12 12 times, so to say. This whole thing is drawn with a scale of 9, but doing the same draw 12 times with a scale of 9 is 108. So you could say this is a move with a scale of 108 actually, because it's 9 times 12. The Smartlists are that optimized that this is not really slower than a move with a corresponding scale of 108. It is perhaps a tiny little bit smaller because these are 2 lines. But if you just have 1 line, then this is exactly as fast as you would draw or move with a larger scale. The the single repetitions in this octo, in this 8 times, they are programmed such that they follow seamlessly one after another and you do not lose any cycles. So what you can actually do is you can draw every object on screen with a scale of 9 with Smartlists. This is why I love the scale of 9. You could also use 10 or 20 or 40, but the tinier the object, the longer it will draw. So 9 is the lowest value I can use for Smartlist. If you use lower values, the Smartlist will be drawn smaller, but it 9 is the minimum. It will not be slower than 9, or a tiny little bit perhaps, but there's a border you cannot go below, because the internal settings of the wire register just take some cycles. It is that way. And everything above 9 cycles is waiting for actually for the drawing to be finished, and below 9 cycles it's actually, you cannot go faster. It does take so many cycles. It's just that the timer will finish earlier and the vector will be smaller. Okay, I hope I'm not too disturbing with my gibberish here. Anyway, it goes from here to here and then starts to move, to draw. Oh man, it starts to draw, and it draws double from to 3a to -49. So it goes somewhere up and left. It goes this way, and then it does again draw another vector, and another vector. All double. That means it's really the scale of 18, not the scale of 9. This goes this until it reaches this point, and this is the large vector I told you about. And this is again octo, because it's so large. It's actually 8 times 9. It will be a scale of approximately 72. And here you can see that this move octo here, this draw octo here, is 100% exactly the same function as the move function, because these functions are stated in the sense of, if it's in the mode move, the light is switched off. If it's in the mode draw, the light is switched on. Everything else is exactly the same. So when this special draw octo is called, then the light is switched on and it draws a line. When this octo is called, the light is switched off, so it's just a move. But otherwise, these functions are these functions are exactly the same. And the light between all these drawing functions is also not switched off. It's one continuous draw from the start draw to whenever the draw ends. And these functions are so optimized that you usually do not see any dots in between. What you can usually see when you draw with other functions, because they have to stop, they have to wait for the timer, the ramp is still continuing or not continuing, and the blank is not off soon enough, and so on and so on and so on. These functions are timed exactly that they always keep the light on, but move at exactly the same time, so that no dots appear. This is, for my taste, the optimum. Perhaps there can be a cycle more or less somewhere, but this is the intention behind these functions anyway. What these functions also know is, you can't see it in this example here, but let's assume that the last x coordinate here was 0, and the next y coordinate would be 0. Then while generating, this function here will be different. This will be a function, I don't know what it's called, y equals last x or something like that. I don't know if they call that, but to the meaning behind it would be that. And this function then would be executed a tiny little fragment faster, because the function internally knows, I don't have to set 0 to the integrators, because this function knows the integrators are already to 0 because it exited the last functions with 0. So every tiny bit of optimization one or I could think of is represented in these smart lists and squeezed everything out of them, so to say. This is the smartness behind the list. The list itself is not smart, but the generation process is smart, so to say. And each line knows exactly what came before, what comes after, how long it is, what scale is best, what's not best, if it should do a double, quattro draw, or whatever. This is what's smart and optimized with these things. Okay, this for the general concept of the smart list. What is confusing a little bit is, perhaps I should have mentioned it earlier, these DB statements stands for data byte, and functions are actual addresses. Addresses on the Vectrex is always 16-bit. To represent one line, one vector in one line, I had to use bytes everywhere. So this is why this function is split in half. This is a high byte value of the function address, and this is low byte value of the function address. Personally, I prefer to have one line in one line. If you do not, there is no high-low. You can execute that, and then you can see these functions are on separate names and separate lines. You can see it like this. Yes. Not 100% sure if this is correct, though. Yes, it is correct. It is. Yes, it is. I have to think about it just now. What you see here, this is the coordinates, as I said, and this is a function, and this is an oct function. This is a single draw function. It starts to draw, and this is a continue function. And this is a continue 3 function. This is again a little bit different. This octo function stores 8 times these vectors. Continues can also happen. This goes from continue 1, I think, to continue 8. This does just mean that this function is always the same for the next 3 lines, or for exactly 3 lines. 3 lines in this case means this belongs together. This is a first draw. This is a corresponding function to this draw, and since it's a 3, this function is also valid for the next line and the next line after. This just as an explanation if you wonder why these 2 lines do not have a separate function. This again a tiny little bit of optimization, both in speed and in size. Okay, enough about the smart list. I'm not going into how they internally work. You can look at the code. This is just how they appear if they are generated, and so you know a little bit what you look at. I don't like this high-low. This is why I'm turning this off. But it was necessary to generate them thus because I also use Smartlists now from C, and I have an automated conversion program that converts data from one assembler to another assembler that's used with a GCC, and the conversion program cannot cope well with these high-low things. This is why this switch is there just for the C generation. Anyway, now what I'm going to talk about is at least these settings you can change here. First thing, yeah, where do I start? I already did start here. This was, if you remember, this was the first checkbox I unchecked. With this special case, I usually uncheck no positioning move. So what is no positioning move? No positioning moves unchecked means there is a positioning move. And this is exactly what I said. For all of these single scenario entries, the list more or less assumes that it is zeroed, and to place them on the screen, it has to move them to this place. With this, you can do these scenario lists. If you have an animation or a single drawing, then you usually want to place the single drawing somewhere on the screen. Let's say you have a tiny little man and wants to walk at the bottom from here to here. Then you can use Smartlists for that too, but the Smartlist should start at the vector, not at the point 0. So you can actually beforehand, before you actually draw your smart list, position the smart list. So what you use internally, you do a move from here to here, print your vector list. In the next round, you do a move from here to here, print your vector list, do a move from here to here, and so on and so on. So it does not make sense to let the smart list move itself. This only makes sense if you use scenarios. So if you want to draw a single vector somewhere on screen, what you do is you switch this on, no positioning move, then everything is drawn from the starting position of this corresponding vector list. Let's see, this is position 0. In this sense, if you move somewhere on screen, this slope here is printed exactly from here, starting it. Right? If this is switched off, it will move to this position and draw it. And this is switched on, then it will start drawing from the position you are at the moment and start drawing here. If I do this with a scenario, it looks stupid. I can show you that. Now, every single list item in this scenario is drawn from position 0 onward. It looks like I don't know, some weird atom thing with electrons swirling around or something like that. But if you look closely or have X-ray eyes, you can see this is a V of a vector blade, which I can't find in this vector. No, it's the second one here. And these are the slopes I talked about, and all are started from the point 0. As said, for scenarios, you should switch this off. For everything else, you switch it on. And most of the time, you switch it actually on. The scenario thing is more or less a special case. Now, I'm going to talk about the other parameters soon. But right now, for the next parameter to make any sense, I have to explain something else. Smart lists. I always talked about smart lists for the scale of 9. The smart lists you cannot scale itself. The smart lists are generated for one specific scale, and this is why I often use the scale 9. This is the optimal scale for me, at least it is. Perhaps there are others, I don't know. But one of the things that the Vectrex is good at is usually scaling. You can enlarge things, you can shrink things, you can do animations by actually changing the scale and so on. This is not possible or not well possible with Smartlists. Smartlists are for one scale only. That means if you want to draw a vector in a list, an object, a sprite in different sizes with using Smartlists, there are 3 possible ways. Either you have different sized vector lists here and draw them with the same smart list, or you have this is actually the same. Or the thing I was going to say, you have to generate the the object for different smart lists. So you do one set. You have one set of smart lists with a scale of 10, maybe one set of smart lists with a scale of 15, and one set of smart lists with a scale of 20. And so once you draw it with this smart list, once with that, and once with the third one. The thing is, the lists are generated for a specific smart list. You cannot say draw it with this smart list and then with that smart list. This scene or this object, so to say, is always drawn with the smart list because the smart list functions are part of the list definition. So still, what you can do is with one set of smart lists use different object sizes, or in the sense of one object generate different smart lists with different sizes. These are two possibilities. And there's one possibility which I do not like, but it exists but does not look good. So I cannot actually say that you should do it. You could actually use a smart list, let's say, generate a smart list with a scale of 20. And with a scale of 20, you could set the actual timer value, the scale it uses, to a lower value. The object will be drawn smaller. So that is what you want to achieve. But as I said before, the light is not switched off between the different lines of an object. And also with these kind of lists, the light will not be switched off. So what this generates is actually lists with the correct size, which are very dotted, because at the end of the scale that you use for your vector, there's a time gap between that and the continuation of the list actually, and that gap is where the bright dot will appear. I don't really know if you can see that in the emulator, but I'll try it. I will load another whatever vector list. What do we have here? This is, oh, okay, why not? This is one vector list, and where is it? I'm just going to center it. Switch this off, and this is, let's just see what this looks like. This is a chopper. This is now generated with a scale of 20. Let's do a very large chopper. Why isn't it a large chopper? Because there is an error. This is what I said. Here now is target out of range. Oh, this is a short branch. This must be, in this case, a long branch. This happened because the scale is so huge, and the weights are actually done with codes. So there's now a out of branch out of dingsens. So this is a chopper with a scale of 80 with smart lists. It looks good. So this smart list is now generated for a scale of 80. We try. Yes, that is very interesting. This is the scale This here is a scale that is actually used for drawing. This is different than the scale the Smartlists was generated for. We can draw it now a little bit smaller, but with a Smartlist built for a larger scale. It's hard to see in Vide actually. It's not so good. You can discern it barely. Here you see a bright dot, below here you see bright dots, there you see dots, but in Vide this is not optimal. On a real Vectrex you would see there are bright dots between every line here, because this line is drawn with a scale of 20 from there to there, and then at this point it waits for the timing difference the Smartlist was created for, and the actual scale we just used to draw. In this case, the Smartlist was generated for $80, and the drawing is done with $1.20. This means this is a dot with a brightness of 60, so to say. It's a very bright dot, and this is between every vector. Yes, you can use smart lists that are generated for a higher scale to print smaller characters on screen using a smaller scale, but it will look ugly. Just believe me. This should not be done. Anyway, the reason I talked about this at all was this field over here. With this field, you can enter a prefix to the function names for the smart list. So this is now a smart list for the scale of 80, which I do not create again because it gets again an error and I have to correct it manually. This is a smart list for the scale of 20. And if I generate it, then you will see all the function names used within the smart list use this function name, and all the functions of the smart list also use this name. And since it sometimes happens that you want different smart lists for different scales, in Vectorblade I think I use 3 different scales. This makes it easy with this tool to generate different smart list settings. Otherwise you had to do a whole lot of replaces in your code. Okay, that one. Old smart lists and Vectorblade smart lists I already talked about. RTS2, usually your smart lists return with this function call to RTS. The smart list itself is usually called just with as any other draw functions. You load your register U with a smart list and then draw the smart list with a subroutine call to draw smart. The combination of U register and draw smart, this is how you draw, and this is a normal subroutine. It will return with a with an RTS to the caller. In Vectorblade, this is also a Vectorblade setting, I generate oftentimes smart lists which return to RTS2, and internally, Vectorblade speaking, this does not return actually to the function caller, but it returns to the object list that is being displayed. This actually, I think, pulls the address from the stack, but not the return address, but the address of the next object to jump to. Yes. You should not bother about it. If you are interested, you can ask me or look at the Vectorblade code. No shift. This is also very much Vectorblade related. As you might know, Vectorblade is a 4-bank cartridge, and the first 2 banks are addressed using the IRQ vector, which is routed through to the cartridge port and thus can be used together with a PB6 extension to form a 2-byte address from 0 to 1 to 2 to 3, and these are the 4 banks that you can address with these settings. The lower bit of this address scheme is the IRQ vector, and the IRQ vector is 0 active, or the IRQ flag is 0 active. So this means if there's no IRQ, then the banks 2 and 3 is active, and if there is IRQ, the banks 0 and 1 are active. So, long talk. If you want to draw vectors in your first 2 banks, where an interrupt must always be active, then you have trouble, because if you use normal drawing functions, these influence your interrupt vector. And there are different ways that you can set interrupts. You can use timers, you can use a shift register, and there are some external lines that can cause an interrupt. What I use most of the time is either T1 timer or the shift register. And for nearly all drawings, I use the shift register to actually create an interrupt and keep the interrupt active while in bank 0 or bank 1. And this means for the smart list to work, I had to program a completely different set of smart lists that do not use the shift registers at all. Internally, all normal vectors are drawn on the Vectrex using two settings. It's the blank register, the blank, it's not register, blank flag, so to say. If blank is active, then as the name says, no light is on, the light is switched off. If blank is not active, then the light is actually switched on. It's vice versa, so to say. And there's a ramp flag. The ramp, if the ramp is active, then the vector beam moves. If the ramp is not active, the vector beam does not move. And to draw a vector, you have always to jiggle with these two flags. And the shift register is actually used to set the blank flag. So with the shift register in normal vector drawings, you control whether the light is switched on or it's switched off. Luckily, there are other ways to switch the light on and off via control register. So I can bypass the shift register completely and use the shift register to generate an interrupt, and do not touch the shift register at all in the bank 0 and bank 1. So the interrupt is always active, and I can draw, and I can activate or deactivate the blank register using other things like the control register. And if this button is switched on, this is a checkbox, then the smart lists that are generated here are generated for no shift smart lists. So still, this is deceiving. The syntax of no shift smart list down here is very slightly different. What this no shift does is only represent the no shift smart list within the actual vector list generation. This no shift flag does not generate the smart list functions for no shift. For whatever reason, I never did that. You could call it a bug, but it still generates the normal list. If you actually want to use it and would like to do no shift functions, you have to do a copy and paste from the vector list, from Vectorblade. They are included there, but not within this generator. The generator can generate the vector lists, but not the functions. Just so you know, and that you do not wonder. Actually, these two you should probably leave alone. Then another set of tricky functions. I don't know if you followed my blog or read or heard anything I said before on video or whatever. You might have encountered me calling some vectexes cranky. And with this, I mean they behave funny, unexpectedly, depending on timing and size values of actually vector lists. These vector lists, as said before, are highly optimized. And in the opposite, the normal BIOS functions are not so highly optimized. But this also means that the BIOS functions are very robust. They are not disturbed by cranky Vectrexes. The crankiness shows itself if there are there are different ways it can show. Usually, this shows if the via B register, B port, is programmed 2 times in a row too fast, one after another. So if you do a store via port B and in the next command also do a store via port B, then on some Vectrexes this is too fast, and the integrator values, the MUX settings, they got jiggled up and the screen looks funny. This is one way that crankiness can appear, and another way is, at least with my Vectrex, and I know of a couple of others, if the actual integrator values, the settings for the DAC, the digital analog converter, are too much opposite of each other, then this also happens to lead to funny things. This on my cranky vectors happens if I usually have a x coordinate with a highly positive value, and directly after that put a high negative value to the y coordinate, to the y integrator. This sometimes juggles up, and both of these settings over here are only there to compensate these crankiness behavior. This is not always needed. What I actually do is I test it out on my cranky Vectrex and see if it looks good. If it looks good, I do not change it. If it looks bad, I do change it. Not every programmer has the comfort of having a cranky Vectrex at hand. I realize that, but it also happens very seldom. So there is no default value with which I can tell this is always working. That's what I said before. You have to test your programs with real-life Vectrex, and similar things can also happen, more seldom, but can also happen with normal Vectrex BIOS functions. Anyway, SmartMax. SmartMax, this is an actual maximum strength that is generated for the vector lists. These are the coordinates, so to say. This is a y coordinate, I said before. This is a x coordinate, and if this is set to 127, then this can at maximum be 7f, and this can be at maximum 7f or minus 7f. If this is set to 100, for example, then this value can never be higher than 100 or lower than 100. So you can compensate for high values of integrator settings. Yes, and low Y. If this is activated, then the smart list generation inside Vide looks if a jump, that what I said before, from a high X value to a very low Y value is larger than the absolute of this. If it is larger, then it generates a different vector list. I set this to a really small value, and perhaps we can see an example in here. Nope. Yes, this one. You can see this is a start draw, and usually the start draw is called start draw single or something like that. And this time it is called start draw YD7. This is 4. I don't know what this stands for. Y is actually the Y coordinate. 4 is additional 4 wait states, and D is, I don't know, is a D. And this happens, I think, because the difference between this coordinate and this coordinate is now higher than 50. Do we have a window open? What is this? 2D? 2D? Oh, man. 2D, what is it? This is 45 and the B is 11 is 55. The difference between these two is 55. This the program deems too high, so it inserts, so to say, an additional wait state here. And the additional wait state means in this case it's a different function which is exactly the same than the start draw function, but with two knobs in between or something like that. Not all of these YD4 functions that can be generated by Vide are implemented, because I said before you cannot implement everything at once, otherwise this would blow up eternally. If something like that happens to you and you use a low Y value, then you have to look up the function that it actually extends. In this case, it extends a start draw single, and look if there are two calls to register B or something like that, or to actually this one is not calls between register B, it's a difference between register A and register port A and port B. But anyway, look at the functions. It's all apparent if you look at them, and you have to just adjust the function then. High low I already explained. Then we go up here. This is not really interesting. This is not really interesting. This is the name of the smart list that is generated. In this case, it would be Chopper. Build list. Then you can see this list is now called Chopper. Scale, I already explained. This is the scale the smart list is created for. The scale is actually not hard-coded in there. The scale is actually declared above here as sprite scale, in this case 20. And if you happen later to use this set of smartlist function for a higher scale, this is possible. You just have to enter here 30 or something like that, or 40. Then this particular smart list is also working for the new scale. The thing is, this thing here is not dynamic. You cannot do it online while the program is running. But while you are programming, you can change the scale of the smart list at any time. There's nothing else generated for a higher scale or a different scale smart list. All that changes is exactly this value behind the sprite scale. Runnable, this runs, this called editor. This is EQDIFs. EQDIFs is interesting. It's a little bit of optimization. Let's do an example. There's a list which is 301 positions long. 301, let's 201. And as said, this is larger than any 8-bit signed value. The program has to split this up. It has different options, so to say, to split this up. It can split it up in 101 and 100. This is exactly the same value. Or it can split it up to the same values, 101 and 101, or 100 and 100. I think what this echo does is it splits it up in the larger portions. So it generates this one, but it splits vectors always in equal distances, even if it's even if it's an odd value, not an even value. This has some advantages, because as shown somewhere else, this one here maybe, if you split this 201 in 101 and 100, then two lists are generated, this, and in this one here there will be 101, and here will be 100. If you split it, however, in equal distances, then you can just generate one function here, and this is then a double function. And it's slightly faster. It uses less memory. And if you have high values in the sense of high coordinates, like over 1000 as before, then this might be split up in, well, end up being split up in 8 different vectors, and then you might have, I don't know if it's realistic, I can't think straight right now, 8 different functions, but if you split it even, then always an octo will be generated or something like that. So this is some sort of optimization scheme here. And now to the last, include brightness. This is not really smart. This is just looking a little bit better. For normal sprite object generation, leave this one off always, because it's slow. It slows everything down. But for the title, I actually programmed these settings here for the title screen, I think. But I'm not sure anymore if I really use it. I would have to look it up. The thing is, when the Vectrex draws on screen with one scale, it always uses for each draw, so to say, the same amount of electrons. Let's say you draw a very short vector like this, and on the other hand draw a long vector like this, and both are drawn with a scale of 60 maybe, then this will be a short vector, this will be a long vector. But what also will happen is this short line will appear much brighter than this long line, because for this little vector, the same amount of electrons are fired onto the screen by the Vectrex, by the hardware. So naturally, this little thing here is much brighter than this long vector over here. And with these settings, I tried to compensate this. If you switch on include brightness information, then you can tell it a minimum value, a minimum brightness that should be used for drawing, a maximum brightness it should be used for drawing, and how to split it. This is in 4 parts, so in this case, this would probably be drawn with 3F, and this would probably be drawn with 1F brightness. And let's assume there are other vectors, like maybe this one and this one. Then this would be 1F, 2F, 1F, 2F, no, something in between, 4. I don't know. 1F, this is 28, this is 30, and this is not 38, but 30F, or whatever. You get my meaning. The brightness is then equally distanced, so to say, with this value and the vectors. The only thing is, the drawback is that brightness setting brightnesses is very time consuming. Not absolutely catastrophic time consuming, but very time consuming. And if you happen to have a vector list, maybe like short, long, short, long, short, long, short, long, short, long. What this brightness setting then will do is, I draw a vector, different brightness, set brightness, draw a vector, short vector, different brightness, long vector, different brightness. So between every vector, it would change the brightness. And if you have got the title screen of Vectorblade, for example, with 180 vectors, in the worst possible case, it would change the brightness 180 times. And even the Smartlists are not fast enough to compensate that. So actually, I don't know if I use it, but that was the reason behind creating this. And it actually does work, but yeah. So now I'm talking longer than 1 hour. And this is enough. And I said before that possibly I will do different sessions for this one. What I will certainly go into is how to use this in your own program, and how to convert easily your own vector lists to smart draw functions, and thus to well, with a really minimum of work, can speed up your own programs if they use BIOS functions or draw sync list or something like that, speed up your programs to double or three times to be double or three times as fast as they are before. And this can be done once you get used to this in very short time. In half an hour, in an hour, you can speed up your program immensely. This is just the background, so to say, for the Smartlists, where they come from, what they do, and a little bit of filling in the technical stuff. I didn't go into too much detail, but this as a background for optimization with the next part of this introduction to Smartlists. I thank you for listening, if you are still listening, and thank you, and goodbye for now.